So hello everyone, this is lecture 34 for the quantum mechanics. In the last lecture we were discussing about the finite square potential and we have completed this and we discussed a lot of questions. So today also we'll discuss some more questions because all that matters is questions that how you gonna solve them in the exams. So it will be very beneficial for you for your understanding to solve more and more questions. So let's see one more question. A particle of mass m is confined in 1D potential well. So this time the conditions are a little bit changed. Means when x is less than 0, it is given that infinite potential. Between 0 to a, it is minus v naught, and for greater than a, it will be 0. So if you plot this, you will get something like this. Means infinite at the 0, and then it is this is x is equal to 0 line and y equal to 0. So it is minus v naught here. This is potential line and this is x line. So it will be 0 here and it is positive infinite and minus v naught, and for x greater than 0 it will be 0. So this kind of potential curve you will get. Now what you need to do is find the minimum depth of potential. If there is at least one boundary state, also plot the wave function and probability density. So see, as we discussed in the finite potential well, when there is something like this, then we have seen that there were even and the odd eigenstates, and there were one means there will be compulsory one eigenstate there was, and we solved the equations for these three reasons and we get that. But here the difference is that at one edge you are getting infinite potential. Now what kind of solution here we get? So we need to solve that again for this kind of potential. Then we'll see that how much boundary states are there, and then we can only find that what is the minimum depth of potential to have at least one boundary state. So let's see. So there are three reasons. For the first reason, let's write the time independent Schrodinger equation. So you know this is the equation form. So for potential that phi x is 0 here. So that means this will be give you phi x equal to 0 here for this kind. Means solution here is nothing but this is equal to 0 because of infinite potential. And let's see for the second reason. For the second reason, you know, here we in place of vx, what we need to write is means you know how to solve this will go this side and it will be v minus e. So this is the case when energy is less than. So here you what will do, see here energy is always negative because it is less than this line. So how you can write the energy is always minus mod of e. So whatever energy is, the overall value will always be negative because it is in the negative region. So if particle is here having the energy minus e, so it will be means here in place of v minus e you will get minus e minus v naught, that will give you v naught minus e. So this kind of equation will be formed here. D square phi 2 by dx square plus 2m by h square v naught minus mod e phi 2 equal to 0. So for this second reason, this will be your equation. I hope you get the idea that why it is always negative, because it is less than means this is just sign convention only. So whatever energy is, it will always be negative because the potential is minus v naught here. So overall will be minus means this is greater than this. So this minus this, it will give you plus v naught. So v naught minus e, this will be here. So that's how we get the solution. Now we just put this whole term as k1 square. So now you can solve this equation. It will give you a cos and b sine. So we already seen that how we get these solutions. So for the second reason, this will be a solution. Now for the third reason, again this will be energy only, means minus e. So in the place of this whole term, you will get minus e. So this will be your equation, d square phi 3 by dx square minus 2m by h square, and this is minus mod e phi 3 equal to 0. Now solution of this equation, let's put this whole term as k2 square. So this will be this d exponential minus k2x plus e exponential k2x. Now see, this is for the third. So in the third reason, you will see that when particle having energy E equal to minus mod e, so at the infinite, this solution must be 0. So at the plus infinite, if you put here, so this will be 0, but this will still be remaining. So to make the solution valid, we need to put this equal to 0. Only then this at this term, whole term will be 0 at x equal to plus infinity. That's why this term will be 0, only solution will be this. Now so this is the case, x at plus infinity, phi 3 will be 0 and equal to 0. Now to solve these equation and to find the solutions, so we need to solve the boundary conditions. So see, at this point there's phi is 0 here, and this must be means phi 1 equal to phi 2 and that must be equal to 0, and here this phi 2 must be equal to phi 3 and that must be equal to 0. So this is boundary condition 1, phi 1 equal to phi 2 at x equal to 0 equal to 0, and phi 2 must be equal to phi 3, and that not need to be 0, only this must be 0 because in this side this phi is 0, that's why this must be equal to this and this must be equal to this is the boundary condition. And now see that potential is finite here. So the second boundary condition, that is d phi 2 by dx equal to d phi 3 by dx, that will also be valid here, only at this point, at x equal to a. So first equation will give us a equal to 0. How? That phi 1 and phi 2, if you will see that phi 1 is 0 and phi 2 must be 0, so it is equal to 0 at x equal to 0. So this will be 0, x equal to 0. This will give you 1 and a equal to 0. So that's how you will get a equal to 0. So phi 2 will be b sine k1x. Now phi 2 at x equal to a must be equal to phi 3. So this is b sine k1a equal to d exponential minus k2a. So this is already 0, so this must be equal to this. Now differentiation of these two must be equal. So we will take d phi 2 by dx, d phi 3 by x. So this will give us this. Now we have these two equations. Now we can solve them to find the solution. So divide this whole equation by this equation. You will get k1 cot k1a equal to minus k2. And just multiply with a here and a here. And put this k1a as beta and k2a as alpha. So you will get solution as b cot beta equal to minus alpha. So this is again our transcendent equation as we get in the finite potential. So again we can't solve it directly. We need graphical solutions, or the numerical, means hidden trial method. So we'll solve this equation by the graphical. So again, this alpha, we know alpha is nothing but k2a, and alpha square plus beta square will give us k1 square plus k2 square divided by a square. So substitute the value of k1 and k2 and you will get this. Now we can just substitute this as r square. So this is again an equation of circle. So as we did in the finite potential case, so we'll again do the same thing, means where these two equations, means first one is this and second one is this one. When these two equations are intersecting at the graph, we get the solution for the beta, and that's how we can find the eigenstates or the eigenenergies for this kind of thing. So summary will be, means a is equal to 0, so phi x is nothing but 0 for x less than 0. b sine kx, means here you can see that this will be 0, so this is for this reason, and phi x is 0 for this reason, and for this reason you will get this d exponential minus k2x. So this is the solution now. And see, here we are getting only antisymmetric case because only sign is there. In the finite potential we have discussed, there were two things, sine and cos. So here you are getting only sine. So let's see what kind of solution we will get and what kind of eigenstates we are getting. So we will plot this alpha and beta, and only cot beta is there, not tan beta. So we'll get only for the cot, that is alpha equal to beta, and that is minus, because of that minus sign we are getting all the positive curves. Because for pi by 2 to pi, cot is negative, but there is also one more negative there, so minus will become plus, and you will get this kind of curves. Now the second equation is alpha square plus beta square equal to r square, this one, and we need to plot this circle. So r is depending on the potential v0. So for different potentials we are getting different circles. So if you see that when the radius is somewhere here, then you are getting no eigenstates, but when it is between pi by 2 to pi, you are getting one eigenstate. When it is 3 by 2 to 2 pi, you are getting two eigenstates. That's how you are getting eigenstates, and that is depending on the potential only. So we can just define when r is 0 to pi by 2, there will be 0 bound states or eigenstates, and when r is pi by 2 to 3 pi by 2, that will be n equal to 1, means between this region you are getting one eigenstate, and between this 3 pi by 2 to 5 pi by 2 you are getting two eigenstates. So that's how now you can just make a general formula from here, that is 2n minus 1, means when r is between this range, then you are getting n number of bound states, and when r is between this range, then v0 will be in this range. So this is the implication, means this implies this, when r is between this region, then v0 will be between this region. Now you can see that when n equal to just 1 here, so it will be 2 minus 1 1, that will be pi by 2, and here it will be 3 pi by 2, means pi by 2 3 pi by 2, and for n equal to 1 you will get first energy state, and here it will be 3, that will give you 9 pi square h square by 2 8 m a square. So this is the same case as we discussed in the finite potential, but here we are getting only the odd states. So now they ask this question that find the minimum depth of potential if there is at least one bound state. So minimum depth of potential means what is the minimum energy required to have the or the potential required to have the one bound state. So you can see that below this pi by 2 there will be no bound state. So we need to find the energy at the pi by 2. So to put n equal to 1 here, just it will give us the minimum potential. So n equal to 1 here will give us pi square h square 8 m square, and here it will be this. So energy must be, or the potential must be between this range to have the one bound state. So that means this is the minimum energy required to have the one bound state. So so this was the question and this is your potential. The answer will be pi square h square divided by 8 ma square. Now there one more kind of question can be asked, that if we note that potential is less than this 4 times pi square h square m square, so how many bound state can be possible? So see, the potential is less than this, so it can be in any of these range. So there is 3 also possible, 2 also possible, 1 also possible, 0 is also possible. So all question will be, means all answer will be right. So that's how they can confuse you. So you must remember this thing, that the potential define that how many eigenstates are possible. So all are possible. So it can be anywhere in the range of this, less than this. That's why all the answers are possible. So if they ask you to plot them, then you can plot them also. Means here all are the sine functions. So it is n equal to 1. You will get something like this. Means here you can see for x less than 0 it will be 0. So here less than 0 it will be 0. And between 0 to a it is sine k1x. So it is sine curve. So it is like this. And now after that it is exponentially decaying greater than a. So you can see that it is decaying exponentially. Now similarly for n equal to 2 you will get this kind of curve and it is again exponentially decaying. So that's how you can plot for the all the eigenstates. And if they ask you to plot the probability, it will be something higher than this and it is like this, always positive. So that's how you can plot the probability also for the other eigenstates also. So I think now you are getting this, and you don't need to solve these questions again and again in this long way. You must remember these results, that how r should be and how v should be. So for different kind of potentials you need to just remember these results. That will be helpful to solve question fastly. So remember them. Now try to solve these questions. I will give you a solution in the next lecture. So it is a good practice. So a particle of mass m is confined in 1D potential well. Vx 0 when x is less than 0, minus v0 when x is 0 to a, and when x is greater than a it will be 0. Find the eigens, functions and number of bound states. So again you need to do the same things. Also plot phi x and mod phi x square, that is probability, and this kind of potential value have. Next question is, a particle of mass m is confined to a finite 1D potential, that is Vx is V0 for mod x is greater than equal to L by 2 and mod x is less than L by 2 is 0. In its ground state, the wave function satisfies the condition phi x equal to a at x equal to 0, phi x equal to root 3 by 2 a at x equal to L by 4. Find the value of the wave function at x equal to L by 2. So solve this and the answer will be a by 2, so you can recheck it or cross check it. Second is, find the ground state energy of the particle and answer will be equal to 2 pi square h square divided by 9 ml square. Consider next question. Consider a particle of mass m confined in Vx equal to 0 when mod x is less than L, V0 when otherwise. The particle is found to be in a bound state with energy equal to E equal to pi square h square 32 ml square. Find V0. So answer will be pi square h square 16 ml square. Consider a system whose wave function at t equal to 0 is psi x equal x0 3 by root 30 phi 1x plus 4 by root 30 phi 2x plus 1 upon root 6 phi 4x, where phi is the wave function of the nth excited state of an infinite square well potential of which say En equal to n square pi square h square 2 m square. Find the expression value of energy, and you know the formula, that is just E1 P1 E2 Pe2. So you can solve this. So try to solve. B part is find psi xt and average expected value of energy. So you know, if they ask you energy at any particular time, that must be same as t equal to 0. So you can just find a time dependent wave function by this equation, how the wave function is evolving, and that will remain same. This result you must remember. A particle of mass m in an infinite value of length a has the following initial wave function at t equal to 0. Psi x0 equal to 2 by root 7a sine pi x by a plus root 6 by 7a sine 2 pi x by a plus 2 by root 7a sine 3 pi x by a. So questions are, if we measure energy, what values will you find and with what probability? Then calculate the expectation value of energy, find psi xt, determine the probability of finding the particle at a time t in the state phi xt 1 upon root a sine 3 pi x by a exponential minus iota e3 t by h cut. Next is, calculate the probability density rho xt and the probability current density jxt. Verify that divergence of jxt plus del rho by del t equal to 0. Next is, consider particle in an infinite square well whose wave function is psi x is given as ax a square minus x square, x is 0 to a is constant, 0 otherwise. Find a so that psi x is normalized. Calculate del x del p and del x del p. Calculate the probability of finding E equal to 25 pi square h square divided by 2m square for a measurement of energy. So try to solve these questions. I will give you the solution definitely in the next lecture, and we will start then the harmonic oscillator. So that's it for today. Thank you everyone.